The star. As we start zooming out here, see the moon. Well, let's talk about the moon just for a second. So if the Earth was a basketball, the moon would be a tennis ball 24 feet away. So it's basically, I'm guessing, the length of this observatory. You got a basketball on one side and a little tennis ball on the other. You can imagine, and so it took the astronauts 3 days to get to the moon in that distance. It's a long ways away. Interesting fact is there's the New Horizons spacecraft that's actually heading to Pluto. It's going to be our first satellite to go to Pluto. We haven't had anything come close to it yet. In fact, if you ever look at Hubble Space Telescope's images of Pluto, they're real blurry. And it's just so far out there. It's more than twice as far, I think, as Jupiter. I mean, it's just really far. It flew past the moon in 9 hours. Whereas you can see the astronauts, it took them 3 days. You can imagine how fast that's moving. They'll go over 50,000 miles an hour. And so it should actually get there. It's been traveling to Pluto for over 9 years. When it left, Pluto was still a planet. So, but it's going to be really neat to get out there and see what's actually going on out there. Let's keep moving out here a little bit in the solar system. Oh, here we go. We're starting to hit some astronomical units. So you'll see terms like astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. So it's just a way of calling out big distances. So all this green globs here are actually the asteroid belt. You'll notice that some of the asteroids are in a nice little tight donut there, and then some actually are kind of in this little, a lot of people call them Mickey Mouse ears here on the side. But what that is that's because that's actually Jupiter's orbit. Jupiter is the largest planet in our solar system, and it's just pulling some of these asteroids, around in its path. They call it the big sweeper or vacuum cleaner of our solar system. And it's got such gravity, anything that flies by, it'll start pulling it in a long tail behind it. So it's just caught quite a bit of these asteroids and pulled it out to its orbit. Let's keep going out here a little bit. Uranus, Neptune, Pluto. So these purple lines are actually a lot of those spacecraft that we were just talking about, like Pioneer 10, Voyager 2, Pioneer 11. So Voyager 1's actually left our solar system. Yeah, I'm going to zoom out. There it is.
Where are they going? Or are they just kind of now on their own sort of leaving?
Yeah, it's still sending signals back, but the reason we say it's left our solar system is because if you think about it for a second, everything's moving. Everything's relative to something. Right now, we just say Voyager is leaving. It's actually just leaving us, right? But think about, remember that big spiral galaxy? It's actually turning, right? So in the space in between stars actually has an influence from the stars that are blowing their solar winds out there, if you can think of it like that. Well, Voyager 1 is not picking up the solar winds from our star any differently or any stronger than the solar winds from the other stars, right? So that's how you know it's left our solar system. And so we actually have what's a little, if you imagine, like, so it is our star in our solar system is actually moving around this big spiral galaxy. And so there's actually a little bow shock, almost like the front of a ship has a little water that spreads away from it. So it's actually just left through that bow shock. All right, let's zoom out just a little bit further.
And this will continue sending signals for a while? And
yeah, it's really faint to pick these up. If you know the big Arecibo telescope array, that thing's gigantic. It can barely pick up that faint signal, but it does. And they just hunt for it and they filter for it. They've been used to it now for, it was launched in the late 1970s, and so they're kind of used to digging out the signal and looking for it. But they still are, and they're getting telemetry from it, so it's great. If we zoom out, I think the next, let me flip this around. 1,000 astronomical units, 3,000 astronomical units, 100,000 astronomical units. There we go. I was looking for the next closest star to the Earth here. You can barely see them up there in the, what is that, 11 o'clock, 10 o'clock position. That's actually Alpha Centauri and Proxima Centauri, a binary system there. And so that just means they're orbiting each other. They're 4.2 and 4.3 light years away, respectively. The exciting news about that is we just found a planet going around Alpha Centauri. Up until a couple of years ago, we did not know if the closest star system to us had even one planet going around it. But now we have satellites dedicated to just looking for planets, like the Kepler telescope, and they're going to launch. Oh, I forget the name of the new telescope. Sorry, but actually, let me show you something on here. Since this is a database, let me jump back on here. Exoplanets, what we were just looking at here, that did all this. This is a free app, by the way, if you have an iPad or iPhone. But since this is a database, you can tell it's tracking the confirmed exoplanets here, 1,881. There's actually thousands and thousands more candidates that aren't on this list. It's actually pretty hard to become a confirmed exoplanet. You have to have enough observatories, see the same planet and confirm it and stuff like that. So it's amazing. I mean, you think of 20 years ago, we did not have this technology. This was the realm of Star Trek and Battlestar Galactica and Star Wars. We can now actually have cameras taking pictures of some of these planets. Not all of them, but it just depends on how far away